This is a tutorial of how to use linear algebra in S2. Please remember, always start with this magical keyword, use S2 or nothing will work. You can hit Shift and Enter in any cell to execute the code in the cell. Matrix and vector. First, we can create vector with dense vector with an array. For example, create a vector of array of double. Creating a matrix is as easy as making a vector. Dense matrix is to create matrix with array of arrays. As for the systematic matrix, we only need to input the values as a lower triangular matrix. Vector and matrix can be printed out with printIn function. We can easily find the transpose of the matrix A, as well as the inverse of this matrix. And for a non-invertible matrix such as non-square matrix, we can find the pseudo-inverse matrix X of this matrix C. Basic operators. In S2, we provide arithmetic operators of vector and matrix. Notice add and minus apply element-wise, while multiple is for matrix product. So matrix dimension must match with each other based on different operators. For example, multiple 2, 3 multiplied by 3 matrix. Indexing. We can get elements from matrix or vector by its index. Notice index for both column and row starts with 1. For example, guess the second element of the first row from matrix A. And we can also select one column or one row from a matrix. Obviously, the row column will be considered as a vector. Matrix measures. S2 provides functions for simple matrix measures. Here's the function to get the determinant of a square matrix, and the function to get the rank of a matrix, as well as the singular values with QR decomposition. Solve linear system of equations. Let's try to use the matrix and vector to solve the equation A multiplied by x equals to b. Assume A is 3 multiplied by 3 matrix A and B is 3 multiplied by 1 vector A. We first need to create a solver for this problem. Then we assign the solver for matrix A. The final step will be getting the solution for Ax equals to b. And we can prove the solution is valid by calculating the product of matrix A and solution X and compare with vector A. As for an underdetermined system of linear equations such as Ax equals to 0, we can also use the solver to find the solution. Let's try to find the vector x that makes matrix B multiplied by x equals to 0. Since there might be multiple solutions, let's try get the first solution and check the matrix product of matrix B and x. Decomposition. We can factor a matrix into the product of one lower triangular matrix and one upper triangular matrix by lower-upper decomposition. It could be done by the little process. Notice the decomposition has a permutation matrix P that satisfies the equation of P multiplied by A equals to L multiplied by U. Singular value decomposition. In order to get singular value, we will need to apply the SVD If we only need the singular matrix sigma, we can simply apply SVD function. The diagonal value of singular matrix is the singular values of matrix A. For those who also need the U and V matrix of the decomposition, the SVD function works like this. We can prove the equation A equals to U sigma V by minus the right side of matrix A. QR decomposition. By QR decomposition, we can decompose a matrix A to an orthogonal matrix Q and an upper triangular matrix R, which satisfy the equation A equals to QR. Let's try to the QR decomposition with the Gram-Schmidt process. We can prove the matrix Q is an orthogonal matrix with and also the equation A equals to QR.